Pim, thank you for joining us. You're the CEO and co-founder of General Intuition. Fellow European, I think we both loved gaming a lot when we were young. Unlike myself, you've actually turned it into a business back in the day, creating the biggest private RuneScape server, and have really had an unconventional path ever since, never really working for anyone. Help me, sort of understand your inner psyche and sort of what's led you, to just chart your own path all these years over the last 15, 20 years.
Yeah. Running private servers on RuneScape is like a free-for-all because it's like half legal, so nobody cares to do things to other people that are highly illegal. Mm-hmm. And so everyone's DDoSing each other, hacking each other all the time. And so to actually get to the top of the private server leaderboards, you have to be really, really good at defending against these types of things. And you also, while it's going on, you have to be able to build a team and code yourself and figure out what the community wants. So it's actually a very sort of general simulation of what running a high stakes business is like, except you are not protected by the law. And
all of this you taught yourself.
Or was forced to learn in many cases when you're being hit in the face with a massive DDoS attack and then figure out how to get things back online or something. So, but usually had to figure it out, and YouTube or just a lot of patience.
Amazing. What was the rough scale of that server back in the day?
So we had 2 million total players. At any given time, there was somewhere between 3,000 and 5,000 concurrent users online on the services. A lot of people played it while they were in school. So a lot of RuneScape players that weren't able to connect to RuneScape during the day because their school IP address was blocked. It would connect to my servers while they were at school, for example, in the libraries, and then also it had a large organic community because RuneScape removed some updates. So yeah, it did a few million a year in revenue. And then we were about 10 people. We were all teenagers. Wow. A lot of people I still work with today.
That's remarkable. Was that sort of you licking blood and you knew you always wanted to be an entrepreneur essentially?
No, I wanted to be an F-16 pilot.
Oh, no way.
Yeah.
Wow.
Yeah.
What happened?
Two things. I'm slightly above the height, and then I have Tourette's, so my eye twitches a bit, which can you imagine if you're flying an F-16 and you go, oh, oops, I didn't mean to down your wing there. Sorry.
A little blink and
yeah,
a lot.
Exactly.
Yeah.
I think it would have not worked out very well. But now I get to make things fly without even having to control them. So
remarkable.
Still worked out in the end.
I think, around sort of your age, 19, 20, you again did something that's sort of non-linear for someone who ultimately started a foundation model lab. I think you worked on Ebola, and afterwards you built a very successful mapping tool. Talk about those two pieces a little bit.
Yeah, they're quite related actually. So I loved hackathons. I would always go and do not coding competitions, but hackathons for the most part, where you actually build products in very short amounts of time, and then there would be a jury where certain products would win. And Dr. Without Borders was one of the sponsors of one of the hackathons that I went to, where I placed second on this hackathon. I don't remember who placed first. And when Ebola hit, they contacted me and said, hey, there's this issue. It looks a lot like what you were dealing with a private server. So it was a Java-based. They were gonna try to use Android devices, which at the time was primarily Java based. Low-level systems who had need to know networking because the tablets were not on consistent internet connections, which was very similar to how I was doing dedicated server management and things like that. Sort of look, we just need one person who kind of understands these things. You were the first person that came to mind. Would you like to come to London? This is really bad. This was my good friend Ivan, and I was like, yeah. And I took one colleague from I was running my private server with. We knew at this time that we had to shut down the private server because the company behind RuneScape was getting sold. And I was over 18 at the time. So it would have been problematic if I didn't. Got on the plane. Got to work on Ebola on the response for maybe 6 months or so. Eventually, Google Christ Response ended up taking on our whole team, and we worked as part of Google Christ Response, and that was really cool. worked on the same floor as a bunch of people from DeepMind at the time, which was it's always, I always find it funny because they also have the gaming origins that at the time I thought what they were doing made no sense. And so this Demis deserves a lot of credit. And then the project Ebola luckily didn't actually become the sort of global threat that sort of COVID ended up being. It was really bad, but it wasn't. It didn't cross borders the same way, and it wasn't as infectious. So it spread through bodily fluids instead of being airborne. So therefore, the great responders were actually able to contain. And by the way that works is the exact same way as a social network. You have a K factor of a virus. If it's 1.01, you're screwed. If it is 0.99, you're good. So it's inverse. And so you basically build these large models to get to this number called the R naught, and then you track like major network points. Like for Ebola, it was funerals and it was truck stops for opposite reasons. And so you track these sort of dependencies just like you would track kind of nodes in a social network, and you work the virus down instead of in a social network try to work it up. So in our case, we worked on building a tablet that you can dip in 0.5% chlorine solution, because everything that had to go into an Ebola treatment center had to be burned, unless you could dip it in 0.5% chlorine solution, or it could be sprayed down. That's why you wear those yellow moon suits. So patient notes, doctors would have to walk to the edge of the treatment center, write it down on this paper while wearing those yellow moon suit, then shout it over the fence, and somebody else would have to take it down on their notes of paper and then enter it into a computer with no internet after walking there. And then they would drive it to a field office, and then we would eventually have some data. And so the response was in that way very non-technical. And we figured if we figured this problem out, then at least we can track what's going on a little bit better. And so did that. Then, like I said, eventually Ebola went away, worked on humanitarian mapping. So what this means is when there's a disaster that breaks out, you typically want to optimize your response for a minimal loss of life, i.e., there's information like if there's playgrounds, you know that there tends to be more children. And so you can actually build these algorithms that look at satellite images in order to do things like minimize loss of life. So I built, this is a very simple example. There's a lot more that goes on, but I built something called MapSwipe, which is essentially data collection algorithm that distributes satellite images to data labelers and then pulls it back into plans
for war zones and
we didn't
disaster areas.
It's areas where it's usually too dangerous to send real mappers to the ground, or areas are inaccessible, like Myanmar, often where it's quite difficult. And usually these maps don't exist for these places because there's usually not a lot of commercial interest to map these areas. So there was about 1 billion people at the time. It's lower now. That were not on maps, and the only way to get them on maps is to go and develop kind of these novel ways of collecting this data. And so it starts with these heat maps to kind of get an idea of like how is the population dispersed, where is low income, high life expectancy, low life expectancy, and then you send over those heat maps to people on something like OpenStreetMap, for example, that actually go and add the labels and then put the full maps together, but at least the responders have something to work with while that's going on. The data on MapSwipe is really cool. It's actually the thing I'm the most proud of in my life. It's way cooler than any of the other things. And
the other things are in the making. Maybe stretching from there, it's sort of remarkable how many chapters you've sort of gone through. Maybe sort of talking a little bit about sort of this new problem space you're going after. You've recently been on an interview with Jan de Koon. He's obviously been, very loud about, LLMs not being the path to AGI. I think you've used sort of this clever analogy of LLMs being the snowball running down a mountain in their auto-regressive manner, being blind to whatever they may hit. Help us explain what a world model actually is, what a policy is, and how these things are just structurally different from what ChatGPT could ever do.
So I'm not in the camp of LLMs are dead end, to be clear. I am in the camp of the most efficient way for a model to learn is through actions and observation. So through taking an action, learning from that action, and then immediately getting feedback. Text is a way to kind of compress the world around you, right? So if I were to describe where we are, I would say, we're in New York, we're in a studio, but I would lose a ton of information about what's actually going on around us, right? If you then try to create a model that can act in an area like this, it has no reference point, right? It understands in text, but actually these are three-dimensional spaces that play out over time, right? And so you need to understand how dynamics of environments play out over time, and text just completely loses that information. And you have to. It's completely unknown how much compute you have to apply or how much data you have to apply in order to recover that information. With world models and with policies, you sort of model this at the level of the architecture, and so you can account for it. My opinion is they kind of end up coexisting. So you have, right, like you could argue, for example, that for problems that exist in text space, like science, it's actually a very efficient way of modeling the world, because a lot of this exists, right? Like, you could argue that for text, actually removing the temporal aspect is very efficient as a compression mechanism. You could also argue that removing spatial information is efficient. And so modeling an already efficient data format for fields that were built entirely on top of text, which is why I suspect, right, you see so much progress in math and code. It could actually just be the most efficient way to model that. You could also take, I've talked to Jan about this, you could also sort of take his view, which is that the token generation and world models are more grounded, and therefore eventually you end up also seeing world models take on these other modalities. My view is, I think text generation ends up being an LLM problem, and environments including spatial temporal dynamics, they become world model problems, and the LLM either calls the world model, or the world model has or policy or the world model could both have text as an option in the output space. Right. And how it plays out exactly is unknown. I don't think that it's one or the other. I think we end up with some combination of the two, and that the modalities that world models and policies end up bringing will be very, very different from an interface like ChatGPT, which is fundamentally a text-based interface.
Your sort of path there was a unique one. I played a lot of video games when I was young. I was always intrigued by, you give a textbook to a kid and like they put it down after 5-10 minutes, and you give them Age of Empires and they solve resource allocation problems for 8-9-10 hours and they're totally fine. It's like they just drip feed complexity at just the right level. You previously built for many years Metal TV. Maybe explain for a second what that actually is, and at what point you realized that you sat on more than what was initially just Metal TV that ultimately led to the start of General Intuition.
So Metal is video recording software that also has integrated social systems. So think of it kind of like Instagram for video games or Snapchat for video games, but it's completely vertically integrated all the way from just like Discord, it runs natively in your computer.
My mouse movements and keyboard strokes are natively recorded as I play the game.
So we don't record the keyboard strokes. We convert them to actions. So walk forward, walk left, walk right for privacy reasons. But that's okay. Like you can, if you have enough at that level, then the model actually just learns
these abstractions.
And so so you get like at very, very high granularity, you get these precise like movements and dynamics that are very, very important for spatial temporal action taking. And if you train a model that can correctly predict actions across these like in this case, like tens of thousands of video games, you have to be a very general intelligence, right? You have to be able to understand interface dynamics, text. In a way to think about it is the digital world lacks physical information, right? The internet lacks the spatial temporal dynamics of the physical world, and the physical world actually lacks dense digital information. And games kind of perfectly merge these two together in a modality that we believe is just the next phase of pre-training. And right, you've seen the models. I think it's increasingly looking like that's the case. And what we realized with Metal is that we had a lot of these pipelines, right? Metal already was processing hundreds of millions of videos a year at that point. We were able to have this large-scale indexed video that we could use. Initially, I thought that we were going to use it for fine-tuning LLMs. So, like, could you take a bunch of Factorio data and use it in order to fine-tune factory benchmarks on different LLMs and see if you could climb it in Factorio, then presumably you use that to generate a lot of similar synthetic data for real world scenarios. You could kind of develop the recipes from the data you already have, and then you could figure out. Anyways, that was the plan. And then we realized that we actually could take it much further, and we had enough of this data to do full from scratch pre-training for new frontier models. And that's when we realized we're not going to go join another lab and work on these sort of relatively to what we're doing now small problems, but instead we're just going to take a shot at the frontier ourselves because we can. Yeah, so far so good.
As with anything, there's always critics, right? There's people who's like, oh, games are cute. They're like these toy environments. They will never really, transfer to the real world. But I think, you have an immense amount of respect for everyone else in this ecosystem, but you think a lot of them are actually fundamentally solving the wrong problem and the wrong bottleneck. Like, help explain that a little bit.
So I view it as everyone is actually modeling the same thing, just in different ways and with different inefficiencies, right? So you could argue for world models and our policies, the inefficiency is text. For LLMs, the inefficiency is spatial temporal dynamics. For world models going at this problem without ground truth action data, it's the actual causal relations between the frames and the actions, right? You have different scaling law for then actually learning and inferring the actions, which also so everyone just has different problems. Everyone has very smart people working on those problems, and so I don't think that it is a situation of we're the only one that can get there. No, I just think we can get there much faster, right? And at the end of the day, our customers are going to judge us on the same evals that they're going to judge frontier LLMs, right? Everyone just wants a very general system that they can throw text and frames at and get really, really good answers. So, I think the way to look at us is we are as focused on spatial temporal dynamics as Anthropic was on code. We're using that as a path to get to the frontier. So we're not saying we're going to win on code. We're saying we're going to be as focused on spatial temporal dynamics with a very general system, and then we expect that is a sufficiently large enough market within robotics and simulation, and then especially once you start doing things like automating scientific loops, right, with inside physical systems, then that things get very, very large very quickly.
It's about time. I grew up in Germany. In Germany, you can't help but think that the highest calling of humankind is to become a mechanical engineer back in the day, and to hopefully work in the world of atoms, not just bits. And I feel like, what I thought was going to be many decades away is probably, much closer than we think. Pim, I'm curious, about 2 years ago, there was a firm that shall not be named that offered you a very large sum of money to sell, and it would have been probably the biggest outcome of your life, and changed the trajectory of your personal finances certainly, and the means you could have pursued your own dreams and endeavors with, and you said no, and ultimately turned this whole thing into general intuition. How hard of a decision was that for you, and how clear-cut was it to just say no to this and then ultimately go and pursue and go full steam ahead at building general intuition yourself?
Yeah, to be honest, it sounds like it was a really hard decision, but it wasn't. first off, we had multiple offers, so we kind of knew that there was a lot there, from very, very smart people. And we had also learned a lot about, and you're right, I had been able to recruit my own research team at the same time. And so it wasn't a particularly difficult decision to walk from big offers, because it was already so clear by that point that we were sitting on the only general solve that we knew of at the time for such a bottleneck. That
The bottleneck being data.
yeah, and that we were very much before consensus, right? Like, we knew that we stumbled upon this way sooner than anybody else. And so we knew we're before consensus.
You had the data.
We had the data. We were able to build a great team. Right. I had already, at a very, very small scale, played around with large scale data, and also I trained very basic models when TensorFlow was still the most popular tool for that. So I was maybe a little overconfident in terms of how hard it would actually be, but I felt like I kind of knew that it was a good bet.
Is there anything that's been harder or easier than you imagined?
Everything is harder.
Fair.
Oh yeah. Yeah, right. Like, theoretically, it was a sound bet, and then you actually get into the nitty gritty of, okay, how do you get this much data onto a bunch of GPUs and train models across thousands of GPUs? That's actually a hard problem. Mm-hmm. And then you have to go and deal with the dynamics of buying compute. And then there was a single day where I spent more money than I would like to admit on this podcast. And so you get into these crazy edge cases where you just need to make the call, but yeah, they're usually very tough calls. And the whole industry is so competitive. I think my friends describe it as the Champions League as a European. It's like you kind of have to grow really quickly and figure it out, because it's the most competitive race in the history of humanity in many ways. And so, for a good reason, but I don't think I was actually grasping that. Like, I just wanted my company not to be screwed from AI, right? So I did it, like, in many ways. I was like, oh, this makes sense for us as a company, because we need to go and make sure that we protect ourselves against the case where actually AI kind of eats the core business, because it's going to be so easy to build these types of things and whatnot. So for me, actually getting into the industry, it was interest, but it was also a defensive move, as it was the right call as CEO. I wasn't like the other Frontier Lab CEOs where I was like, oh, I want to be the guy that does AGI. I actually had no absolute interest in any of that. And so I kind of got to the race just by doing one step in front of the other, and now I'm like, oh, crap, it's actually really hard. But we're doing well. I think everyone is crushing it at the team, and we're just rolling with it. We're having fun with it. We're rolling with it, and things are looking great.
It's been remarkable to see progress. I won't share much, but it's, every couple of weeks I come and visit, and you see new emergent capabilities, and they're so orthogonal to what you see in LLM world. And, it's remarkable. Maybe for people for whom this is still very abstract, how do you articulate to them the things that GI may one day enable that previously aren't tractable?
Yeah. So right now, if you ask any of the Frontier Lab APIs, you send them a frame of, let's say, a robot in a room, and you ask it to walk to X. It cannot do it, right? Because it has no understanding of time, or you're seeing a single frame, right? So you have to imagine how many workloads are spatial temporal workloads. Anytime when you're controlling a physics engine, you're dealing with a spatial temporal workload. Even simple things as like bots in video games, spatial temporal workload. you've seen the navigation capabilities of, for example, some robots. They're spatial temporal problems. You see frontier robots that kind of have specialized models for their embodiments. Those are spatial temporal problems. And so it's really about closing the loop on the atomic world. Like, you kind of have three stages, right? Bits to bits, bits to atoms, and then atoms to atoms. And I think solving spatial temporal dynamics is actually just how you solve all the way. And then because text is largely commoditized, right? There's great open source text models. You can kind of assume, in my opinion, that you can import a lot of the capabilities that were done in the text domain. And if you can win the frontier on the atoms to atoms race, then you can actually supplement on a lot of the other areas by winning there. Because that's where the bottleneck is, right? So you win that bottleneck the same way that sort of Anthropic won the code bottleneck, and then you work backwards from there. And so, yeah, robots, bots in video games. I think it will also be very, very useful for synthetic data generation for science. So the lab is named after when Demis Hassabis from DeepMind tried to train a AI agent to play foldit in order to generate data for AlphaFold. Mm-hmm. And they eventually landed on just other methods. But if you can unlock a general agent that can follow rules and then act in spatial temporal environments, you unlock massive use cases in science as well. And eventually, right, you can then close the loop, or if you have a physical system that can then also see whether those systems reproduce in the real world, then you can have a complete end-to-end loop to accelerate science, for example. And so if you solve spatial temporal dynamics and control in a very general way, at the level of, in our case, controlling things the way that gamers control things, so like game controllers, which almost every robot ships with, right? Mm-hmm. Or keyboard and mouse, for example, then you actually have a very general solve for the atoms to atoms stage of AI. And so we're kind of taking the bet that largely a lot of companies are overcomplicating the problem by trying to do like prediction at the level of the motor torque or something like that. And you can actually just predict at the level of the gamer and have a much more general approach that gets to market much faster.
So Pim, I wanted to circle back to something you briefly said earlier when you were talking about, clearly not wanting to take the acquisition offer, in part because you felt so good about the team. Funny little side note is I think you hold the record of most GCers recruited. You've managed to assemble one of the strongest teams in the space and have managed to recruit some of the world's best researchers, many from the Diamond Paper and others. Like, what's drawing people to the company?
The main thing is because they want to work with all the best people. So I think a lot of the time it's self-reinforcing, where if you have the best researchers, the best engineers, they all want to work with that team. And then also when you bring a group of the best together and then they get the results they want, then it becomes even easier to go and recruit the next batch of the best people. Mm-hmm. So we were able to first get obviously the top research in the field, and then we're now also able to get like the best kernel engineer. Like it kind of like goes and trickles down into just you get to kind of get the top of everything, and so you just repeat the system. But I think like cold emailing, right? So the research team was literally cold email. And most things in my life have been cold emails. Then also not being kind of afraid to challenge them, right? So I think in my case, I actually learned how to do this stuff at like a very basic level before I went and actually engaged with them, and so we were able to have a bit of a back and forth. And right, my background's engineering, they're researchers, and they're more on the scientific side. So we had like, it was very clear that it was a very natural fit. And like I think I told you this before, but I view it as like the kitchens and the chefs. So our internal sort of mandate is my job is to build the kitchen, and the researchers are the chefs. They actually use the tools available to them to build the best recipes and to get the best results. But my job is making sure they have all that available when they need it, and think 6 to 12 months ahead in terms of what they might need next. And so that, I think, has just led to both the best teams in the world across engineering and research, and we already had, because of Metal, very, very large scale video pipelines. So we were able to reuse a lot of the work that we had used already to get a very quick head start on data processing and things like that. Yeah.
Amazing. I wanted to sort of finish almost on this full circle moment where, coming back to RuneScape. I think some of the people you played with, I think you're still in touch with, right? And maybe some of them you
I work with them, yeah.
Call friends or colleagues.
Yeah.
What do you sort of personally want to protect about this awkward gaming industry that's like non-algorithmic in many ways, and gave refuge to so many of us in our childhoods, that you want to really protect with general intuition or more broadly?
Yeah, for us, we really exist to serve the games industry, so we don't build models that compete with game developers. We focus on models that predict actions, right? We use world models in service of those models, but the business is not to launch products that compete with game developers. The reason for that is because I actually believe that all the game developers are sitting on the means to win themselves in this race. I also think that it would be a shame if what is largely considered kind of the last real weird place on the internet, in the best possible way I say that, right? It's people were going to have fun, it's creative, there's in the way that things inside the web browser often aren't, right? People are social, that needs to remain a thing. And I think if we let it get eaten by large kind of general internet media companies, then that becomes threatened. And so our goal is to empower the developers to build more quirky, in many ways, but hopefully also money-making things that then they can use in a very general way, like many ways what OpenAI did with their API, right? Like starting a company before OpenAI launched their API was very different than after. All of a sudden, all these new possibilities were there, and I think if we enable that for the games industry and simulation at large, and then robotics, that will become a very good outcome for us.
Amazing.
Yeah.
Thank you so much, Pim. This is not a job interview.
Huh?